Welcome to GTMA's webinar, the last in our Guardrail series and asset management. Today we have with us, we actually have a substitute this morning in one of our speakers. Richard Arrowsmith will be joining us. He is the group leader with the Asset Information Group for Highways England. And he will be replacing Jan Savorn. And then we have Mark Jenkins, who is with the IBI Group. As most of you know, we have been conducting at GTMA a series related to how agencies are addressing issues related to asset management, specifically to guardrail assets. We've had a number of issues here in the United States related to inspection, installation, and an understanding of how guardrail is performing in service. Today we are going to hear from, or regarding how the highway agency in the UK is using various technologies to address a number of asset management issues. Highways England is a relatively new organization. Just went live, I believe, in April, and it is a new format for how to manage major networks, in which the highway agency has now been turned into a private sector organization that is owned by the public sector. So we're excited today to have our speakers who will address issues related to the agency, what it oversees, and how it is using some of these new LiDAR-related tools to improve the way they manage assets. Again, our first speaker will be Richard Arrowsmith with Highways England, and our second speaker will be Mark Jenkins. I would encourage you, if you have questions, to please use to type them out in the questions bar that you see to the right, and those questions will come to me. And at the end of the presentations today, I will share those questions with our speakers, and we will work through them one at a time. And with that, we'll turn this over to Richard Arrowsmith. Thanks, gentlemen.
Okay, good morning, everybody, and thank you for this opportunity to talk to you this morning. It is the afternoon here in the UK, but good morning. As in the introduction, my name is Richard Arrowsmith. I head the Asset Information Group in Highways England, and my group has a responsibility for all aspects of capturing and improving the information that we have about our assets, as well as improving our ability to make decisions and overall improving the maturity of our asset management capability within the organisation. So it is a complex portfolio of work. My job today is really just to provide an introduction to the work that we have been doing around mobile mapping and how we're using that to improve our asset management capability. Before we get on to, if you like, the main body of the presentation, I'm just going to cover some aspects around a little bit of background about who Highways England are, and perhaps outline to you some of the challenges that we've had to date. So the strategic road network in the United Kingdom is probably the biggest and single most important piece of infrastructure within the United Kingdom. The United Kingdom is the 6th largest economy in the world, and the strategic road network is responsible for about 52% of all freight and all movement of commercial activities within the United Kingdom. It's a fairly complex network, and as I said, covers the whole of England, so serves something like around 55 million people. At the moment we have something like 35,000 kilometres, so something like about 28,000 miles of highways. We've got about 12,000 kilometres of earthworks, so that's about 9,000 miles, something like 18,000 bridges and other types of structures. Obviously we have an enormous amount of guardrail and safety fencing, something close to 20,000 miles worth, 150,000 technology assets, and an enormous number of drainage and grey water assets. To put that into some sort of context, I believe we are something like the 6th largest owner-operator by net replacement value of assets in the world. And within the UK, I believe we're the 2nd largest operator of drainage assets. We're the 2nd largest operator of greenfield assets after the Forestry Commission. We are certainly actually strangely not the largest operator of roads, because you know, you look at the size of a lot more of the local roads, we're somewhat smaller, but as in terms of economic importance, the motorways, the A roads, our main strategic roads are at the absolute core of our network. And it is a fairly difficult network. We don't have a huge amount of capacity within our roads. We are a small island, and a lot of our cities are quite linear, so we actually only have 2 or 3 very long roads that tend to take an enormous amount of our traffic, but it is absolutely vital to the UK, and it's really important that we improve the capability of that so that we can actually improve economic growth as we come out of the back of the recent recession that I think has affected everybody. So as part of that, the government has had a huge ambition about improving our road network, and to do that effectively we've had to understand like never before how many assets that we have, the condition of those assets, the state of those assets, and bring them all together into a place in which we can make those decisions either effective, which bring good efficiency and allow us to actually maintain and improve that asset, you know, with the money that's being invested into it. Looking back, we have struggled, as I think a lot of asset operators have done, with understanding our inventory. We just haven't had enough knowledge of how many assets that we have. So for example, currently on our drainage assets, we have something like less than 20% of our assets known to us. On other asset types, things like highways and, if you like, vehicle restraint systems or sort of safety barrier, we kind of were comfortable around 55 to 60% in terms of inventory, which obviously left a lot that we didn't know about, but also we've had some pretty serious problems around understanding the condition of that. So we've made a very concerted effort over the last 2 to 3 years to improve our understanding of our inventory and the condition information that underpins that. And the rest of this presentation, I think it's looking at one of the key ways that we're doing to understand our inventory, of which we are using that as a foundation going forward to improve our condition understanding as well. I think at that point it's probably a good opportunity to pass across to Mark. So if you'll just forgive any noise on the line, I'm just going to pass you across.
Good morning, everyone, or good afternoon, as it may be, wherever you are. So I'm just going to take you through the remainder of the slide pack now, just to show you the benefits of mobile mapping system as the Highways England see it, some of the outputs of the mobile mapping system in terms of feature extraction requirement, the primary uses of the mobile mapping surveys in terms of asset inventory, and quite a few slides on the possible secondary uses of mobile mapping as well, apart from the initial driver behind asset information. And hopefully at the end, I'm going to try and give you a live demonstration of a software product Highways England has developed to access and visualize asset information alongside imagery and LiDAR. So as a bit of a scene setter, we need to consider the benefits of mobile mapping surveys. Now, what we're looking at is using the right sensor for the right solution. And rolling back a little bit in terms of the history of Highways England's use of mobile mapping data, it probably goes back to 2012, where the Highways England first used mobile mapping in one of its maintenance areas to look at its guardrail condition, which is obviously one of the focuses of today's presentation, but also the many uses of the data sets thereafter. So, in terms of inventory, as we all know, with good asset management, and the key to good asset management is having better information that leads to better decisions. And obviously a key driver behind all that is improving the quality of Highways England's asset information, which is always the what and the where, and obviously also the condition as well. And above all, accurate locational information of assets. In the past, and as with many asset management systems, they were linear referenced, so by a section and by a certain distance along the carriageway. And there's a gradual move these days over to more spatial data sets, be that in X and Y, and also in Z. So you get much better information of where your asset actually exists. In terms of the data sets, the imagery enables Highways England and its stakeholders to better visualize its asset with confidence, so they're up to date, and also enables contextual visualization of works on the network. In terms of the LiDAR, it enables accurate measurements from the desktop. As I mentioned earlier on, Highways England have developed a product known as AVIS, which is the Asset Visualization Information System, which gives mass access to these data sets to enable measurements to be taken from the desktop or images to be viewed from the desktop. And most importantly at all is using the LiDAR for as many secondary applications as possible. So it's the old adage, collect once, use many times. So all in all, Highways England see mobile mapping as a safer way to get the information they need to better manage their asset. So that reduces the risk to road workers. So many traditional surveys such as asset inventory collection or topographic mapping can be done from the office environment these days compared to people walking around the network putting themselves at risk. It allows check, analysis and verification. So in terms of Highways England's supply chain, it allows that check and challenge of works carried out on the network when you're looking at cyclic surveys. And all in all, it wraps up into major cost savings, the cash flow benefits of using these systems. So to take you through the sort of highlights of the mobile mapping deliverable, as Highways England procures its mobile mapping surveys, as we stand today, there's a national data collection contract in place, which splits into two areas, a northern and a southern region. Each of those areas are around about 7,000 carriageway kilometres apiece. These surveys are going to be carried out over a 2-year period under the initial framework. So there's going to be a complete collection of mobile mapping in 2015 and 2016. So in terms of the deliverables of the raw data, we have imagery, LiDAR and positioning. So imagery-wise, it's georeferenced to within 500 mil of its absolute position to 2 sigma or 95% accuracy. The images are stills, they're not video, they're JPEGs. Up to 5 megapixel or down to 2.8 megapixel is the minimum. The images are triggered on a distance at 2 meters, so that allows enough contextual information to be gathered whilst not overloading a storage system with too many images. You could trigger these systems at a greater frequency, but there's no actual tangible benefit to more and more images. You just increase storage and space massively. In terms of the LiDAR point cloud, the data, once it's processed, is provided in 2 states, matched to within 30 millimeters of its coincidental position, so planimetric mapping, matching on an interval roughly 100 meters usually, and again at 2 sigma, and also unmatched. And the reason why Highways England require matched and unmatched data, because that feeds into different processing streams, which I'll go into a little bit later on. One of the key requirements of the specification is 500 points per square meter on the road surface with no obscurity. So that means the contractors have to cover the network at least twice and up to 3 times. So typically, lane 1 is driven during the day, so that allows simultaneous imagery and LiDAR to be captured, also a nighttime capture to ensure there's no obscurification by any sort of transient objects such as vehicles, and for that density to be maximized. So with multiple survey runs, so in lane 1 and lane 2 and opposing directions on the carriageway, you can have up to 4 runs, and with that the expectation is an interpoint spacing between individual laser points on the hard surface of 100 millimeters or less, and that's relative to all the hard surfaces, so traffic lanes, hard shoulder, slip roads, roundabouts, etc. In terms of a classification, Highways England have a pretty unique classification called road hard surface. So for all intents and purposes, it is a ground classification as such, but that's constrained by a 3D polyline which is generated from the road edge, which I'll go into a little bit later. So when the point cloud is data mined for feature extraction, you can work on specific elements of the surfacing only and remove all the other LiDAR points into the data set. In terms of intensity, which is a measure of the reflected energy back from the surface, it's 16-bit, so for want of a better word, 65,000 different shades of color can be derived from the LiDAR point cloud. And also the number of returns are also stored, and again, a return is the number of points you get or number of hits you get from an individual laser. So in terms of when it hits a hard surface, you'll get a first and single return, whilst inversely on vegetated areas such as grass or even trees, you may get multiple returns. One point to note, there is no requirement in the specification to colorize the point cloud. The main reasons behind that is to maximize or reduce the storage of the LiDAR point cloud. Every time you colorize a LiDAR point, you introduce up to 10, 11 digits worth of information for every single LiDAR point, which can substantially increase the LiDAR point cloud size. In terms of positioning, and this is more relative to the LiDAR point cloud, there is an absolute requirement of less than 30 millimeters. So that's to your datum, and again within 2 sigma, so a 95% compliance to give some flexibility for road points, and also down to 10 millimeters or better, relatively speaking. So that's interpoint accuracy, so that's the best you can get out of a LiDAR sensor. There's also a requirement in the specification around large reconstruction projects, or major projects as they're known as in the UK, to have the absolute accuracy matching the relative. So that's where site known control points are installed and the point cloud readjusted to get the maximum accuracy you can possibly get from the point cloud. In terms of feature extraction deliverables, the key thing for the initial round of the mobile mapping data collection was collection of surface visible inventory, and ultimately to populate Highways England's asset management system. So in terms of these 63 visible surface features, we're looking at things such as road markings, road studs, curbs, signage, lighting, fence lines, structures. There's many, many different asset types. Apart from actually extracting the geospatial location of the asset, there's a considerable amount of attribution of the assets as well. So in terms of the shape of an asset, the height of an asset, or gaps and widths and lengths and so on. And some of them are up to 10 or 15 attributes. Probably worst case is signs and guardrail, where there's many, many different attributes which must be added to that data. The output is 2D lines and points, which are delivered as either a CSV or a 2-dimensional Esri shapefile. With the ultimate goal of the asset data is to take these new features and amalgamate them with existing assets held within the agency's management system to ensure that the asset data is complete and accurate whilst not losing any maintenance history in terms of intervention or defects associated with the historical asset data. So ultimately you'll end up with a very accurate asset data set with all your maintenance history which goes back over many years. In terms of the imagery, they're also redacted. I've got a slide following this one which I'll speak a little bit about a bit more. But there is a requirement to redact vehicle registration plates and the public or driver faces out of the imagery and blur it, very similar to the likes of Google Street View, under sort of privacy protection and what have you. And as I alluded to earlier on, there is a road hard surface polygon that's extracted from the point cloud, and that allows the hard surface feature classification to be defined. This slide just shows an example of the imagery reduction process. So you can see on the top screen, you can see vehicle registration plates, and below it, the redacted imagery with the plate blurred out, and to the right, the same process for a face. Now, the next set of slides, there's probably 7 or 8 of these, are all based upon secondary using of mobile mapping data. The first one is topographic mapping, probably one of the most common uses of mobile mapping across the world. These are primarily done for Highways England major projects, so known as the Smart Motorway Programme, which is all lane running schemes. So there's a requirement to extract topographic mapping down to 10mm accuracy, reference that data back to the originating asset, and to retain that asset record and that link all the way through the project lifecycle back into the management system at the end of the project, so you don't break the cycle of good asset management. And the topographic mapping deliverable is 3-dimensional, not 2. So you'll see in the top left-hand slide, it's just showing you a 2D perspective, but in reality, all of the topographic mapping produced is truly 3-dimensional. So that allows the population or the starting point for building information systems. So this data can be used as a key input into that design process. Another use of the mobile mapping data sets, probably more on a sort of scheme-based level, not on, excuse me, my slides keep moving, is surface contouring and profiling. So this is taking the highly dense hits on the road surface and taking the hard surface classification and data mining that to extract contours and longitudinal profiles into the data set. So for instance, in terms of lanes, you would extract the near side, the offside wheel track in each running lane, and maybe the all track lane as well, 3-dimensionally, and create 3-dimensional polygons. And that allows the creation of longitudinal profiles. So you can start to interrogate the data in terms of water flow direction, in terms of its gradient and crossflow, and to assist in the design of schemes. In terms of the contouring, there's 2 examples up in the top left and the bottom right of the outputs of contouring. So you have in your bottom right your traditional contour, so your lines at your set interval. But we've also created some rasters based upon the contours, just to give a bit more visual context to what you're looking at. Sometimes engineers find it hard to read contours, but the JPEG gives a lot more detailed information about the road surface. So it's much more at an aggregated level compared to what you would produce from a longitudinal profile. And it allows detailed analysis on your surface in relation to, for instance, your gully locations. So this slide is looking at highway geometry. And again, reusing the LiDAR data set and the 3D polylines that are created from the initial deliverable. That will allow the extraction of geometric features from the LiDAR point cloud. So in terms of vertical curvature, horizontal curvature, gradient, crossfall can all be data mined from the point cloud and compared to current design standards. Obviously, all of the roads across the world will be built at a point in time, but design standards are never static. They change and they move. So this allows design checks of a road as it stands today against current standards, and it allows the end user to see if that road is still fit for its intended purpose. Apart from looking at the geometry of the road itself, we've also can extract or perform sightline analysis. So your road user perspective, let's say to a road sign, and you can check to see if that road user perspective and that sightline is compliant with design standards, or is there something interfering with that sightline, which could be vegetation, for instance, or even something more static. So this is probably one of the slides which is probably of greatest interest, and said one of the initial projects we worked upon with mobile mapping is looking at guardrail condition. We know where the guardrails are. That comes from the asset inventory. So there's a line on a map, tells you where all your guardrails are, tells you the profile of the guardrail, but it doesn't tell you the condition. And a very important condition measure for guardrails is its mounting height. Obviously, all mounting heights are specified for different types of guardrail to ensure that it's set at the right height. So if there is a collision with the guardrail, vehicles do not go under or do not go over these guardrails. So we, with Highways England, developed a method using the LiDAR derivative to extract the mounting heights from the guardrails, and a validation process throughout to ensure what we were extracting was accurate. The process, in a nutshell, is digitizing in three-dimensionally the apex of the guardrails from the point cloud. Also using or extracting the road edge information. The reason why we need to know where the road edge, in the UK, the mounting height compliance of a guardrail is dependent on its offset from the carriageway. So if the guardrail is greater than 1.5 meters away from the carriageway, its mounting height is relative to immediately below it, and it's within 1.5 meters, the mounting height is relative to the hard surface on the carriageway. So that must be known for a height compliance. Next in the process is defining the profile. So as the apex of the guardrail is being extracted, we also populate a field with the profile type. Because guardrails in the UK, different profile types have different depths, and for us to be able to establish the mounting height, we need to take away, for instance, the midpoint mounting height away from the guardrail, because the apex of the guardrail is not the mounting height. The mounting height is the midpoint on the profile itself. Next, we established all the mounting heights, calculated where there was non-compliance with the current standards, and we also mapped areas of potential concern with historical accident information. In this instance, we were using wet skidding accidents from the UK Stats 19 information system to highlight potential areas of high or low guardrail where there's been historical wet skidding accidents. In terms of validation of the mounting heights, because this was the first time this was used in the UK, a great deal of effort went in to in situ validation. So teams of surveyors would go out to specific locations, establish the mounting height, let's say in the traditional way, by using levels and dipping, and we compared that to the extracted guardrail lengths, which were extracted, by the way, to 10-meter lengths in total. So we could take a spot height, we could look at the average 10-meter length, and we could say yes or no, it matched the extracted point cloud height. And every time, it did. So we knew there was a robust and reliable way to extract guardrails on the network. And this initial project was 1,500 lane kilometers long. So it's a substantial project. This slide shows you looking at surfacing defects. Highways England has, over the last 2 years, been carrying out a lot of additional applied research into LiDAR to see what else could be gleaned from it. So we know all the standard deliverables of mobile mapping, topographic mapping, etc., but what else could you do with it? So IBI Group were engaged with Highways England to go away and look at some applied research to see what else could be extracted from it. And this is one of the outputs, is looking at surfacing defects. Now, in terms of pavement engineering, we're not considering outputs of other well-known survey data sets. In the UK, it's known as tracks. North America, Aaron type surveys, these types of surveys where they're looking at detailed sub-millimeter or 2 millimeter cracking, or fretting, or map cracking, for instance. Highways England is more interested in how thin surfacings in the UK deteriorate, which they can deteriorate very, very quickly, dependent upon weather and what have you. So this method we developed is looking at, or is using the elevation profile derived from the point cloud. That's by a means of using rasters, then using a method of machine vision to be able to differentiate in heights in terms of color, and from that polygons or two-dimensional polygons were extracted. As you can see in the top left-hand corner, you can see the state of the surfacing relative to the image below. And the circle up in the top left in black compared to the green dot on the bottom right-hand corner just gives you an example of how precise the system is. So this is it's not actually a defect, it's a core hole which has not been reinstated correctly, or it's started to deteriorate, and that's been picked up by the process. So from this data set we can derive a lot of surface-based deterioration. So features such as joint deterioration, potholing, even structural deformation when it's within the measurable range of the LiDAR sensors, which is, as I said before, 10 millimeters relatively. So that's plus or minus 10. So anything bigger than plus or minus 10 millimeters can be detected within the point cloud, extracted, and these condition indicators taken from it. So this slide is Highways England's asset visualization system. So again, coming back probably over 12 months or so, Highways England wanted to explore new ways of accessing data. So not your traditional forms, your tables, your charts, and your maps. Moreover, a new way of accessing information. So that is in relation, let's say, to imagery, or even through the LiDAR point cloud. And from a platform perspective, cloud-based, which is very challenging to say the least. Accessing imagery over the internet or via the cloud is doable. Google Street have been doing it for many, many years. But to be able to access and download a point cloud from the cloud is very, very difficult to do. And in a second, I'm going to try and give you a live demonstration of the software. So that gives you a feel for the speed of the data and how quickly you can access the information. And I think this is one of the key areas where many people, there's an oversight in terms of mobile mapping. It's usually extract a feature, ignore the point cloud. Colorize the point cloud from an image and ignore it. But the imagery and the point cloud can be used for a lot of ad hoc visualization of the network and ad hoc measurements. And it saves considerable amounts of time and money by carrying out these processes from the desktop, from the office environment, compared to mobilizing to site, having traffic management required, and taking, let's say, a headroom clearance of a bridge. So I'm just going to flip the presentation now to the live viewer. So this is the AVIS project as it stands. So we have the mobile mapping derivatives, which is the imagery and the LiDAR. We've also got the asset information which has been extracted from the mobile mapping data sets, also loaded into the system, alongside some contextual information in terms of mapping. So we have some background mapping here. In the UK, it's Ordnance Survey, which is our master map, which is the most accurate mapping we've got in the UK. And we also integrate the data with a linear referencing system. So the user will always know where they are in terms of spatially, in terms of coordinates, but also the linear referencing system, which can be seen down here. So we're in the section, and so far down the road in terms of chainage. We have the road name and survey date, and also the coordinates of where the system is currently placed. So in very general terms, you can move around the interface by clicking on the map. And playing through. Hopefully the connection on the webinar is good enough you can get the real-time view of how quickly this is playing.
It looks good.
You can flip to different parts of the carriageway, as you can see me doing here, and play it through. You can flip to different camera angles. So here I'm looking at the left. Or even I can flip to the rear camera and play that through. And that alone, apart from the LiDAR, is a very, very powerful tool. So it does stop people going out to the network. As you can see in this example here, I don't know if you can make it out. It's an example of the imagery reduction. You can see the plate in the background here where it's been blurred out. So I suppose probably one of the most interesting things is looking at the LiDAR point cloud. So I'm just going to switch over to a structure. So the way the system works, it's all about coordinates. So we have the coordinates of where we are currently on the network, and this will be passed to the LiDAR viewer, which I'm going to click on now. So I hope you would agree that's pretty damn quick in terms of loading. That was less than 3 seconds. So that's a 30-meter LiDAR point cloud around the position we're located here on the structure. To start off with, we cheated a little bit. We reduced the point cloud density. Here we're at a 6:1 ratio, as demonstrated here, but we can bring that down to a 2:1 ratio and make it even denser. I'm not sure if anybody timed that. That was roughly about the same time, 2 to 3 seconds. And now we've got an extremely dense LiDAR point cloud. In terms of visualization of the point cloud, we have a few tools in here. So we have intensity. So again, as I mentioned before, the amount of reflected energy back from the surface. We can colorize this in many different ways. So we have sliders, so you can make things a little easier on the eye, pull them up or down. There's also a trim tool. So you can trim by intensity to remove either high or low intensity objects. So here I'm removing the road surface and leaving higher intensity objects, which is the vegetation and the structure, for instance. And we can also color by height. So again, sort of rainbow-based type features, and just helps you make sense of the LiDAR data set a little bit easier. And here I'm trimming. If I don't trim, it purely just colors it by height. If I trim down, I can get rid of anything, for instance, apart from the road surface. And there's a useful spin-off from using height to colorize a point cloud. If I take it down very, very low to the road surface, and if I zoom out, you can see instantly there's a change in the surface color relative to the height. So we can see here green through to yellow, so it shows me the cross-fall of water on the carriageway. I'm just going to show you some of the tools that's been developed now to take measurements from the LiDAR point cloud. We have three: a free measurement tool, a plumb tool, and a geometry tool. So in terms of free measurements, I just spin the point cloud round and looking vertically. The free measurement tool here, I'm just going to measure the carriageway width, for instance. So it's a simple case of clicking between the 2 points of interest, and your measurements are populated in here. So you have your X, Y's and Z's, you have your length, and actually you have your height as well. So that's the differential in Z between the two locations. So you know you've got crossfall across the carriageway. And the width measurement here is 3.64 meters. UK standard road width for a motorway is 3.65 meters. So that's pretty damn close. And you can see it's snapped to the surface. So it's taken the lowest points. If now we consider taking more sort of three-dimensional measurements, so now I'm going to look at the structure and look at headroom clearance. So we have a cross-section tool, which simply, if you align yourself to the place you want to take a cross-section through, click, and you have an instant cross-section. That can be reduced down to make it very, very fine. So you know you're measuring at one place, not others. Because measuring in 3D is never an easy thing. And now I'm going to look at mounting heights. Headroom clearance is this structure. So we have a plumb tool, and I'm just going to simply start clicking here, click somewhere else, and the tool automatically snaps to the point immediately below the first point. So the first click here in Z, it will find the nearest point in Z immediately below it. So I don't need to worry about, as a user, all the fiddly bits of trying to measure in 3D. And as a test, if I spin the point cloud round, there we go. Everything measured on a single plane. So I've measured from left to right across the carriageway here. And in terms of measurements, we have 571, 554, 539, 527. So I can derive two things from that. One, the pinch point is here in terms of headroom clearance. So that's comparing the 571 to the 527. And also, I know that the lowest point on the carriageway surface, by definition, is here. So in terms of gradient, the water would flow from right to left across the carriageway. So if I just turn the cross-section tool off here and get rid of all my past measurements, now we're going to look at geometry, which is the last tool to show you. So this is given more information in terms of Z. So here I'm going to measure across the whole carriageway now. My first click was on the left and my right click was on the right side. So now we've got the length, the height and the slope angle. So we know the first click was 8.1 and the second was 8.31. So as I said before, crossfall from right to left across the carriageway, a height of 220 millimeters across the carriageway, and a slope angle of 1.1 degrees, which is fairly standard for our UK road network. I'll just show you one more example of geometric measurements. So here now we're going to flip to a slip road and load the LiDAR one more time. And this is automatically a 2-in-1 now, so again, very, very quick. So here you can see more form in terms of the point cloud. So firstly, I'm just going to do one more geometric measurement. So here we're going to look at slope. So I've clicked approximately the top of the slope and the bottom of the slope. You can see here. And down here we have our slope information. So we have a height between the top of the embankment and the bottom, 4.5 meters, slope length of nearly 11, and a slope angle of 24 degrees. Now, just to show you very briefly, we'll quickly look at guardrails before we finish the presentation. This is not how we extract guardrails en masse, but this is an example of how you can measure a guardrail using this system. So first of all, I'm going to constrain the data set. And we have more tools here to chop down the point cloud, which allows me to just focus in on specific areas of interest. I'll do the same in Z as well. So now if I zoom in, just change the color slightly. Hopefully you can just make out the guardrail in the point cloud here. I'm just going to trim this down a little bit more to get rid of the background. There we go. So that leaves you your guardrail, for the most part, still in the point cloud. So what I'm going to do now is take a plumb measurement. This is very approximate. This is not the way we would extract en masse. So I've taken 3 measurements, just to zoom out, spin around, and you can see those measurements are pretty tight on the guardrail itself. And here we have our mounting heights. So 600 millimeters, 600 millimeters, and 500 mil. I would say probably the last one, because I've been a bit rough and ready. I've probably picked up something on underneath the guardrail, which is probably a bit of vegetation. Okay, so that pretty well gives you most of the information relative to the LiDAR and the imagery. Just to show you one last thing is the inventory. So just to give you a sense of scale of the information picked up by Highways England in terms of asset data. Here you can see the quantum of information picked up. As hopefully you would agree, that's an extremely rich data set. 64 asset types picked up in 2 dimensions with a very, very rich attribution of the information as well. And this is just an example of some of the attributes we're collecting. So here I've picked up on a tree, just coincidentally, and we have the type of tree, an owner which is a code, which relates to Highways England, the service area, who currently maintains the asset data, eastings, northings, something we call XSP in the UK, which is our cross-sectional position, so which is a linear offset for the asset data. And all of these layers are searchable, so you can search for anything on the map layer whatsoever. So if you're interested in let's say a diagram number for a sign, or a guardrail of a certain profile, you can search this mapping layer and go straight to that data set. So that pretty well concludes our presentation. So if I'll just pass you back on to Robert, and we can pick up on some Q&A. So thank you.
Excellent, excellent presentation. We have lots of questions, as you can imagine. Let's start off with question, does the LiDAR survey get funded through standard channels, or were special funds secured for it?
It gets funded from the budgets which are allocated to asset information governance. So I get obviously we bid for an amount of funds to undertake various types of information gathering on the network, and we used some of that money, and I would actually say it's been really very good value. How much information we've been able to abstract from this and actually how quickly we've been able to move forward. We've been able to allocate funding to do it. So if you like, it is that we bid annually or every 5 years for amount of money, and then within the group we allocate that, and we looked at this a couple of years ago and decided that we were going to fund it from our normal budgets that we've received. Does that answer the question, or?
Yes, I think so. I guess when you say you bid, is that like an internal discussion in which you have all of the different programs within the I guess the company now, and is that routine, or is it an external process?
No, so as a public funded organisation, we initially have to bid for funding from government, so from Her Majesty's Treasury, and that's something called spending review. So every 3 to 5 years, it's exactly the same as a federal process within the United States, that we would go forward with a proposed bidding process in which we would identify things that we need to do, some of them routine, some of them extraordinary, and we would put that forward through to Treasury, and that would be compared and contrasted against a whole range of other government processes, so be that education, be that defence, be that rail, be that airports, and through a fairly difficult and slow process, and so over the last few years it's actually my group that's been responsible for doing that for Highways Agency. We've been able to identify a certain amount of money that we wish to improve our network information. On a benefits basis, we can demonstrate to Her Majesty's Treasury that actually we can make better and improved decisions through better information. And therefore, we're bidding for a certain amount of money to improve our underlying asset information, and therefore we can get a benefit from that, from better decision making. And that process goes on in the UK every 3 to 5 years. I'm sure that you're probably aware that there's a general election going on in the UK at the moment, and much of the focus on that is actually about future spending plans. And that's at the moment is happening at quite a high level, a department level, but it's all fed up from, and the emphasis going forward is going to be spending cuts. So anything that we can do that demonstrates a long-term benefit, and asset information is one of those spaces, we tend to get the support of Treasury, and we tend to be able to spend money in those areas.
So you're able to use the data that you're collecting here as part of your presentations to policymakers. Is that fair?
Yeah, absolutely. In two ways. First of all, the information that we have gathered, we can actually run through our decision support tools. So they're analytical packages that are able to demonstrate to Treasury the different investment scenarios that we can undertake, and if you like, identify programs of work that we think give the best service levels to our customer for the right amount of spend. So that doesn't necessarily mean the lowest amount of money. What we're trying to do is find an optimal spend which balances whole life cost benefits, over the long term with short-term spending restrictions. So yes, we use that information to make our decision support tools better. And what we can also do, and I think this is why we've recognised some of the added value of visualisation. It's sometimes really difficult for customers and politicians to get a context to this. So a good example is that in the last spending review we identified some fairly significant problems around pavement defects, and that was to do with thin surfacing delamination. And that's really difficult for a politician or somebody within Treasury, for an example, an economist, to understand. Using this type of package, we can actually show them examples on the network of where the surface is delaminating. These are really high definition images, and actually Mark didn't show, but we can click onto these In fact, it might show you now. They can give you a really high definition image, which we can use in the safety of an office environment. We can actually show politicians, key stakeholders, even customers, what we really mean by the defects that we're trying to address. And there have been even examples where we can almost say, well, you show us the location, you tell us where you want to go, and we'll go there, and actually we'll be able to show to you, those defects. And that's very powerful because a lot of politicians, a lot of people within Treasury know that when we put a case together, it's obviously one that we want to present. So giving them the opportunity to be able to go in and look at our network is really powerful, and it's something we're working really closely with our regulator. So as we've changed status as a company, we now have a regulator who are kind of a go-between us and government, and they are really interested in being able to access this information so they independently can gather understanding of what our asset and our network is looking like. And that's why this is such a powerful tool.
So it's creating additional transparency throughout the policy-making decision and helping to inform the investment decisions.
Absolutely. Transparency and context. I think they're two words that I think it's a really good point. I think as being an asset management professional over the last few years, I think asset management generally has struggled to define itself. It is it's come from an engineering background, but it isn't an engineering discipline. It's actually a very a multifaceted discipline. We've got economists, we've got engineers, we've got performance managers, information managers, and all of them actually, if you can provide visual high-definition imagery to those and a simple way to navigate, it makes everything real to them. So it's something that can actually bring disparate professional communities together because they can make decisions in and around something that everybody can actually get used to, which is a visual image. A good example of that is I was driving on a road. I was visiting relatives. I was with my wife and daughter in the car, and both of them were saying, well, this road doesn't look in very good condition. And I said, yeah, I know what you mean. So when we actually got to our destination, I was able to log onto the system independently. I was able to bring the information really quickly. We were able to have a look at it. I was able to say, yeah, look, there you are, you can see that. And then when I got back into work the following week, I was able actually to go back to one of the regions who are managing this and saying, look, if my wife can pick this up, who's a primary school teacher, and my daughter of 5 can say, oh, this road doesn't look in very good condition. What does that mean for the rest of our customers? And by the way, here's the information, here's the visual image that does that. Bit of a busman's holiday, but it does show you how powerful this is for people of a wide range of disciplines actually be able to interact with asset information. And for that, I think it's most valuable.
Excellent, excellent. All right, there was a question regarding the spacing for the imagery and why you chose the spacing you did. Mark, any comment on that?
Yeah, it was just from experience, Robert. Imagery spacing is crucial when you're trying to visualize an asset and extract information from it. If you space them further apart than that, let's say 5 or even 10 meters, you can't get close enough to the feature to get the information you want, especially when it comes down to, let's say, an ID. If you just see in the example I showed just now, where we have a sign here. In the full image, I can read the ID because I'm close enough to it. But if the image was spaced at 5 meters, the closest I could get was 5 meters away from the point of perspective. And you wouldn't be able to read that information, even on a 5 megapixel image. And on the other side of the equation, you could bring the image spacing down. You could go to 1 meter. You could go to less than 1 meter. But there's no derivable benefit from having twice or even 4 times as much images. So it's an optimum. It's enough images to get the information you want, but not too many.
Okay, well, what was the average data storage size per mile or per kilometer?
Good question. Quite large. In terms of the images, they are compressed using a lossy compression method, up to a 1 in 30. because it's not feasible to hold a full-size uncompressed image. So they are compressed. You do have a small drop-off of quality, but not a great deal. So a typical image may be in the region of 400 to 500 kilobytes, thereabouts. It does depend what's actually in the image. Typically compression, if you've got, in the example here, a fairly white sky, that's highly compressed. But when it's more detailed, the compression ratio drops. So it does vary considerably. In terms of the LiDAR, you're probably looking about around about a gigabyte per kilometer. That's very rough, because it again will vary depending on the number of runs you do, and obviously what it's hitting as well.
Okay. We have a question about to what degree, if any, are the data findings provided, modified, or unmodified to the public? If it is provided, what value aims or the scope, and if not, to what degree is the data internally restricted? And what are the different concerns as far as value for the public versus the cost of making it available?
Okay, that's a good question that I think it's something we are exploring. At the moment, we are not distributing this to the public. We have certainly taken the approach that the information is fit for purpose with regard to distribution. Hence why we've kind of redacted the images, and certainly within the UK there are huge sensitivities about the privacy of information, so we have adhered to all the standards around that. We do recognise, though, that there is potentially a lot of value to our customers of doing this, and we have had conversations with Google to that effect. We are looking at our customers and how they interact with images on our network. And we have had some preliminary conversations, but there is nothing yet emerging about whether we would be able to provide this data set to somebody like Google to replace their normal Street View images, which, if you think, are only actually updated perhaps every 5 to 7 years, where this gives something annually. And given how our network changes, there is a real value to being able to provide our customers to that about different road markings and different layouts. But there is an interesting point which Google have come back for, which is people make really real usage in terms of perhaps actually driving the route before they take it in an unknown area within urban areas, but perhaps on strategic road networks, highways, motorways, freeways, if you like, because they're sort of only getting on and off at junctions. What value is, if you like, in updating that information? And as we've kind of counterpointed out, actually junctions is where we do a lot of modifications to road layout, road signage, sort of white markings, etc. And I suppose the way I would say at the moment is that the jury's still out on the value of this information to our customers, and whether somebody such as Google is somebody we could work with, or whether within our own sort of websites and whether our own way of getting information out that we're going to make this public. I think the only other sensitivity that we have is we do recognise that, if you like, there are some security implications around this, and there are certain data sets, there are certain structures which we deem to be obviously critical UK infrastructure that we know has a vulnerability from a security angle, and as we do now with other information sets, those that we would withhold those, or we would withhold those if we felt there was a threat to national security on them. But generally, we want to get this information out, and we want to find ways of using it with our public. I think, in all honesty, though, whilst we're having those conversations, I think there's so many rich areas that we still wish to explore internally, and that really is our focus. This is such a rich vein. And we've only really started to make this usable within our business over the last 6 to 12 months. We're already generating real benefits off it. I think we totted up some of the cashable benefits, which have already exceeded sort of about £1 million just off savings of topographical surveying. There's plenty of other things that we're looking at. We're rolling out the actual AVIS environment, and we're training people almost as we speak. From next week we start rolling that out, because we do want to make sure people are equipped to get value from this. You know, this has a high impact. You look at it, it sparks a lot of interest, and then people say, but how is it actually going to change the way I do our work? So we're putting a lot of investment with our own internal customers to make sure that they can use the tools, that they can actually get something out of the visualization, and that we're offering to them situations and scenarios where they can actually get value from the product. What we hope from that is that builds up some momentum, it builds up some interaction, and that our customers will start demanding additional capability from us that we'll be able to service. I think a lot of asset management systems are about building that relationship with your customers, your internal customers, and actually getting them to use the data. Otherwise, almost it can overwhelm them. You can go from something from nothing to everything, and people are going, well, how does this actually change my job? So at the moment, most of our effort, I think, is really around internal customers.
All right, very good. Well, one of the questions is, to what degree from a practical experience does heavy commercial traffic complicate LiDAR data capture?
Yeah, it is a significant consideration when you're surveying these types of networks. You know, the Highway England network is, you know, substantially used network, so it's not a good idea to be surveying during peak times on specific routes. So we have to pick and choose when we do these routes accordingly. So during the day, obviously you've got to do day runs because you need the imagery. So that's when we would survey lane 1. And you're always going to get, you know, somebody in lane 2 or lane 3 overtaking you, because we generally survey at a slightly slower speed than HGVs, for instance. So you all get, you know, obscurification to the right side of the vehicle, as we do in the UK. So that's why there's a secondary path then at night when the network's considerably quieter, where we do a lane 2 run, and then we pick up the LiDAR that's missed by hitting that transient object in the first place.
All right. Did the Photolog system predate AVIS, and if so, was the LiDAR viewer built into the Photolog?
The imagery in LiDAR was originally collected, well, first started to be collected in 2012, 2013. And the AVIS product has been in development probably over the last year or so. So it can now consume cyclic data. So that's an interesting proposition as well. So you can look at a view of the network from, you know, year 1, year 2, year 3, year 4, and also your LiDAR. So you can see how things change over time.
All right. Is there an automated method of extracting measurements such as the guardrail height, or is the process completely manual?
It's semi-automated. You know, there's a lot of automated extraction you can do from a LiDAR point cloud by using the number of returns or the classification, or even where it is spatially, to be able to start to extract that. But you do run into technical issues. It's never going to be 100%. So some of the apex extraction is done semi-automatically, but there's quite a bit of manual intervention as well. So a good, for instance, is when there's a break. You know, you might be looking in the central reserve, extracting the apex height, and then you hit a structure, and the system doesn't know what to do. So then you've got to intervene again. So it is semi-automated, and practically everything that's been used, the imagery or even the point cloud, through the presentation is a mixture of semi-automated feature extraction. So there's some human intervention, some bits using the likes of machine vision or automated routines in COT software.
Okay. Have you done a return on investment yet analysis on this, or is it still in the phase of trying to determine what cost versus return?
Yeah, we kind of operate a continuous return on investment approach on this. You know, it was we put together a business case right from the very start in terms of internal justification of spend, and we're monitoring the returns on that, and it's really healthy. As I said, the beauty of it was that we were able to describe a clear financial benefit through the replacement of localized topographical surveys. So before going on to a major project, a major renewal or refurbishment on our network, we would have routinely undertaken some form of topographical surveying, some sort of local surveying, what we were able to do was clearly show a percentage return against that, which tends to have paid for this. So all the additional benefits that we believe that we wanted to explore, or the other opportunities, are almost freebies, because we've been able to justify doing it just on that simple one-off, of which I think, really in the last 6 months we've already looking at multi-million-pound savings. Everything else is something that we can explore in real time, and when the benefits emerge we can capture them. But it also gives us some opportunity to try things free from having to make a return, because it's already paying for itself, and that's actually a really healthy position to be in. And actually, a good example of that is some of the condition monitoring, this use of rasters to actually try and identify sort of pavement defects or defects in other areas. It is exploratory. We've got some confidence. Our initial returns on what we're doing are really good. It looks like we're doing it, but I don't actually have to justify the return on it, because I've already paid for it through just the simple additions to the normal surveying that we're already doing. So it's really healthy for us from that angle.
Well, the focus of this webinar was asset management. Is this being used as a roadway safety tool, or even a forensic analysis tool for determining the causation of crashes?
That's an interesting question. I think that would be my hope. But I think we would recognize that, like a lot of infrastructure management organizations, we are, and one that is, if you like, an engineering business, we are very siloed. We're very micro in focus. So the communities that perhaps have traditionally looked at safety or looked at particular causational effects and particular investigating the cause of accidents are quite small, and they're quite siloed. I think they have also invested in their own technologies and their own data sets. So there was reference made to Stats 19, and a lot of work has been done within the UK, within Highways Agency and Highways England, around extracting information from Stats 19 and being able to link that to other systems. I think what we're doing here, and I think this is, if you like, what's going on in a lot of organisations, is we're trying to take a more corporate approach to asset management. It's that collect it once, use it many times. But I think overcoming those silos and actually being able to build confidence within all of those communities, and actually sort of saying to them that, yeah, maybe it's not invented here, or perhaps maybe you have to do things in a slightly different way, but the benefits of us all making decisions and analysis of common data sets outweighs that. But that still has to be done at a local level with those groups of people, and it's slow and it's steady work. So there are communities perhaps that we are focusing on immediately. So we're certainly doing a lot of work immediately around our maintenance management communities and our supply chain communities, and trying to get them to understand the applications of this. And from that, other communities, like those people who are looking at safety, perhaps even the police, and the people who investigate at the same time. So we're starting to explore whether immediately after an accident a LiDAR scan can be done, and we're working with the police to do that, so that we can look at the post and pre sort of incident and accident location, and be able to look for causal analysis there. So there's lots of opportunities from this. There's lots of opportunities from these data sets for everything that we do, but I suppose we have to recognise that we can only manage a certain amount of sort of penetration and embedment within the business, and we'll have to do it on a case-by-case, day-by-day basis.
All right. Well, regarding crossfall, does Avis provide a tool to automatically find locations where crossfall is below a certain threshold and direction of water flow from lane to lane?
Okay, well, the point where the AVIS tool has been developed today, you can only get the contour or the crossfall information by doing your geometric measurements. So it is, ad hoc, very, very discrete measurements. But there probably are plans in the future to further develop the product, and one of the key areas is looking at contouring. And I think that's an interesting position as well, because a lot of features are extracted out from, especially LiDAR point clouds, by professionals using very expensive hardware and very expensive software, which is all well and good. I'm in that business, so it's all, it's all good stuff. However, there's lots of simple processing which could be done through a product such as this to reduce those costs. And contouring is one of the easy ones. We have the road edge polygon, so that constrains the contouring to the carriageway only. And then, to run a contour on it is a pretty basic spatial process to do. So that will probably come in the future.
If I could just come in there as well, from a policy position, that is one of our clear intents. So I'm sure, as you will know, is that England or Great Britain is known for rainfall, and we are a wet country. We do have a lot of rainfall, and we have some clear governmental targets around dealing with the consequences of climate change. For the UK going forward, our climate is going to get warmer and it's going to get wetter, and we're going to get into more of these deluge type rainfall, and it's serious, and we're starting to see that on our network now. We know that's going to impact us in 2 or 3 ways. It's going to change the rate in which our assets deteriorate, but historically our network of drainage and our roads were designed for a certain type of kind of continuous rainfall of long wet periods. We did have an engineering overload design into them still with silting, but with the deluge type rainfalls which we're starting to experience, these almost monsoon type conditions we get, what we are seeing is a lot more standing water, and we're seeing problems with regard to cyclical maintenance of our existing drains in terms of they're being pushed to the absolute limit, so they feel they need to be cleansed properly, they need to be maintained appropriately. So therefore something that allows us to see the profile of the road in some sort of automatic way, which can highlight those areas in which we've got certain areas of the network which may not have for whatever reason no longer have the right sort of profile to deal with getting the water off the carriageway quickly, and also analysing, and that's why this is so powerful, that relationship between where we know we've got drainage assets as well as standing water issues. So it may well be that it's not actually the profile of the road, but it's actually where we may have a maintenance problem in terms of the actual drains, are absolutely vital to us going forward. And we have some clear governmental targets around addressing climate change and making sure our network is fit for purpose against the expected change in climate, and therefore improving our ability to automate that and extract from this information that can guide our maintenance business to potential hotspots on the network is absolutely vital to us. So it's a really important area for us going forward to support development of.
How about retroreflectivity? Are you able to extract retroreflectivity?
I knew somebody was going to ask something like that. As a part of the research we have been doing over the past year or 18 months or so, is looking, as I said before, looking at what's possible, what else can be done with a LiDAR point cloud. And looking at road markings was one of the key assets where I think a lot of people would recognize there could be a real tangible benefit from getting condition information about your road markings. Now in the UK we've got 2 indicators for road marking condition. One is the wear, and the other is also the retroreflectivity. Through the research we've undertaken to date, and again, it is applied research, it's quick, get out there, get it working, and get something on the network. We've developed a method which can measure road marking wear, and there's an interesting issue with road marking wear, because if you're, it comes back to the previous question about automation from LiDAR point clouds. yes, you can automate the extraction of road markings from a point cloud. That's quite a tangible thing to do today. Lots of COT software products do that. But if your road marking is so highly worn, there is no distinct intensity change between the road marking and its background, i.e. the road surface, you won't be able to detect it. So therefore, you've missed the most worn road markings on the network, which is a fundamental flaw in a process. So the way we approached it with Highways England is to use the asset data as the foundation. So you know where the road markings are because they've been extracted visually. An attribute of the road markings, you know the length of the road marking, the gap and the width. So you know the geometric properties, and you can work out for let's say, a discrete road marking what the area should be if it was fully compliant with the specification in terms of its size and not worn. So let's say, a road marking of a dimension should be, let's say, a square meter. Let's pick a number out of the air. And the method we've developed takes that asset data, so it consumes that. So the process knows where the road marking should be. It knows the geometric properties, so it knows the 100% area or perimeter that road marking should have if it wasn't worn at all. And then we use some COTS products and a bit of smarts to then extract the road marking data using intensity from the road surface classification. And then it's as simple as taking one away from the other. So for, let's say, a 100-meter section, your average intensity area, perimeter, from your extracted road marking is, let's say, 5 square meters. And the perfect road marking should be 6. So therefore, one over the other will give you the percentage where. It's relatively quite straightforward, but key is good asset data in the first place. If you haven't got good asset data, it doesn't work. Come back to the question of intensity and retroflectivity. Intensity is not a stable measurement. It's very, very relative, and there is lots of issues around trying to get stable intensity. There's lots of institutions been looking at it over many, many years, especially from the aerial perspective. And there are temporal considerations to consider, hardware considerations, even environmental considerations, and the target surface. It's extremely complex to do. From the work we've done to date, at a point in time, we can derive a very, very strong relationship between intensity and retroflectivity of a road marking. So going back to your handheld base observation. However, you can go out on another occasion, another day, another time, and that relationship would slightly change. Not a massive amount, but it would change. And we've done some testing over a period of 24 hours, and testing every 2 hours the same road markings on the network, and we could see there was a change in intensity relationship with retroflectivity throughout the 24-hour period. It was stronger at night, it was weaker during the day, which is a little odd because LiDAR isn't in the same spectral range as solar radiation. It's well beyond that, 1500 nanometers compared to the visible light spectrum. So the LiDAR shouldn't be influenced by light. However, the road marking surface is influenced by light. It's not a uniform surface. It's Lambertian, I think, for want of a better word. Look it up if you're not sure what that means. But it's not uniform how it reflects light. And that's some of the issues we're looking at, hopefully, over the next 12 months or so. We might be able to get to the bottom of it and come up with another solution, but we don't know. It's a work in progress.
I think there'll be a lot of interest, certainly in the U.S. A number of states are hoping to be able to figure out a way to calculate the retroreflectivity for both markings and signs from the LiDAR point cloud.
Yeah, as I said, you can identify those features fairly easily in the point cloud because of their high intensity nature. But it's been able to establish a consistent relationship. And also, we're aware of the many different techniques that are used today. The high-speed laser techniques, or even imaging-based techniques that's used in North America, for instance, which they're great and they deliver. But it's another system, it's another vehicle on the network, it's another cost. And if you can derive the same from mobile mapping, again, it's that collect once, use many times.
So there is a question about whether this is survey or mapping grade. How would you describe the accuracy?
Okay, I would describe it as survey grade. The specification Highway England has developed is for the most part outcome based, but there is some prescriptive requirements in there. So in terms of the sensors, there's two. The reason why the two sensors are specified is to reduce obscurity from transit objects such as vehicles and so on. And also the absolute accuracy of the sensor is specified. So for instance, you've got to get down to 10 millimeters relative accuracy. You're not going to get that from a mapping grade sensor. That might be 20, 30, 50 millimeters. And you've got to be very, very careful in terms of your point cloud processing to make sure you derive those accuracies as well. It's not just about the sensor. It's also about the processing.
Okay, so some of this has to do with, go ahead.
Yeah, I was just going to say as well, it was really important when we went down this that we wanted to demonstrate that you could achieve, surveying grade accuracies without necessarily the cost or the impact of the traditional routes. So though that we don't see this as being a replacement for something like tracks in the short term, we always wanted to be able to do a comparison and say whether we could achieve that. So by moving towards that sort of like 10 mil, that 10 mil accuracy regime, which we're pushing further now with ground control. We really do, and we've looked at sort of like our peer organisations, so the equivalents of us for rail within the UK and for other utility operators, and actually the standards we're achieving is exceeding all of those, and that's really important to us. We want to be on the curve of pushing the boundary of the technology here, and we can see real benefits from being able to demonstrate through the level of surveying accuracy, real hard cashable savings by moving away from perhaps those high intensity, more traditional surveying techniques like tracks over to something that's actually cheaper to deploy and actually far more frequent to deploy. And that way we can get much more information about how those assets are changing over time, and affordability is really important for that.
All right. There's a question regarding the ramps. Did you collect all of your ramps as well?
Ramps, yeah. Slip roads we call them in the UK, but I get the gist. Yes. In real terms, I mentioned the number of passes on the mainline carriageway. So we do a lane 1 and a lane 2, but in real terms, there's actually 3 passes because the ramps, roundabout type features, which are quite common in the UK, and also off carriageway laybys are also collected. So all of the Highways England network has been driven over, so there's no gaps.
Okay.
I was going to say, one of the things that we're trying to do now is to talk to partner organisations, other utility organisations, so that we can share this information. So a good example is Network Rail. Network Rail are the operators of railway infrastructure within the United Kingdom. We share many locations in which our assets are really close, whether they cross each other, and therefore by working with them to be able to share this data, as well as the other utility companies, so those water, gas, electricity operators, it makes all our lives easier. Often we find most of the disruptions to one of our major projects is understanding whose pipe this is in the ground, whose electricity cable has gone across. So if we can get into this, capture it once, use it many times, share it many times, along with other organisations, there's many advantages. So not only are we doing ramps, not only we are looking at other assets, we're about to explore the opportunity of what we call strategic diversion routes. So these are roads that are not within our direct control, but if we were to get a serious accident or an incident on our network, we have to route the traffic off onto local authority roads. Given how heavily demanded our roads are and how few we have, that can cause massive implications for local authority road operators. So by actually being able to survey those, are they fit for purpose, are they able to cope with HGV traffic, we can see loads of knock-on benefits. And so we really do want to see this to be an all-encompassing series of asset information in and around our assets that we share with others and we utilise with others.
Well, gentlemen, this has been an amazingly quick hour and a half, but our time is now up. I just want to thank you both for your presentation today and for taking so much time to go through these questions. There are actually more questions. And so let me just say to everyone, we will be, a recording of this presentation has been collected, and we will be uploading that along with a link to the presentation, contact information for both Mark and Richard, and so that you'll have a chance to ask them questions via email. But I think we're in a very exciting time. There are a number of states within the United States that are utilizing similar technologies. I just returned from the GIST conference, the AASHTO conference. Nearly 25 states all had LiDAR as something they are exploring. I know that multiple states have system-wide data collections that they are working with right now. And so I thought, and I have thoroughly enjoyed this presentation. I think to the extent that we can share information, that would be helpful over time as well. And so you can expect GTMA to continue with these types of webinars and to incorporate as much as possible presentations on what is happening not just here in the United States, but around the world. And so Mark and Richard, thank you both for your presentation today.
Well, you're very welcome. Yeah, thank you very much.
And with that, we will end the webinar. Thank you very much.